So we have here a classic problem where it's a whole bunch of letters. And if you actually try to read all of this and sort it out in your head, it's possible, but you're doing it the hard way. And I want to show you how to do this a much easier and much quicker way. And we're going to focus first on these three statements right here. These are true statements, and I'm going to use those to build a picture. Anytime you can draw a picture of the math, you're winning. Okay, if you can draw what's going on, it's going to be a whole lot easier to keep it in your head than if you're trying to think in terms of equations and things. Equations have their place, but not in a problem like this. So what I want to do is say all elements are elements of E. All elements of B are elements of E. Well, let's draw a picture. This is E. And if all elements of B are elements of E, then that means B is something like this. B is the smaller thing inside of E. Okay, that's that first statement right there. Let's highlight that and we'll keep track of these things this way. Okay, next statement. Let's make this red. The next statement says all elements of G are elements of F. Okay, so I have two new letters. That's interesting. So if I'm going to take my two new letters and draw them like this, I'm going to say all elements of G. So G must be sort of inside F, like that. Okay, and then no elements of F are elements of E. Well, by good luck, I happen to draw it that way. But maybe you might have been unlucky in how you chose to draw it, and you might have drawn it like this. Okay, well, there's nothing wrong with what I'm showing you right here in the picture by the first two statements, but by the time you get to the third statement, you know it's wrong because F and E are not supposed to overlap. So I have to keep those separate. Okay, there we go. So F and E are not in common. Everything that's inside G is also inside F. Everything that's inside B is inside E. So now let's go through these statements over here and talk about which one of these things have to be true. Okay, based on the picture on the right. Let's look at the first one. All elements of G are elements of E. Well, that's clearly wrong, right? You can just see it in the picture. G is not any way related to E. So that's gone. No elements of F are elements of G. Well, that's not true because all the elements of F, which are inside this little space, are inside G. Okay, so unfortunately, that is also a false statement because all that stuff that's inside G is also inside F. No elements of B are elements of F. That's a winner right there. If you take a look at this, here's all the elements inside B. Are any of them inside F? No. That's our true statement right there. Okay, so that's the process you have to go through with a problem like this. Anytime you can draw it, you're winning.